Hello everyone. In this series of videos, we will be discussing the concepts which are required to answer a quantitative aptitude part of CAT examination. So in this particular video, we'll be discussing about algebra. So what you can expect from this video is we will be discussing what level of questions come in CAT so far as algebra is concerned, and what is the weightage of algebra in CAT. We will also be looking at the linear equations and quadratic equations and the graphical representations of the linear equations. So let's begin. So coming to the weightage, we can say that algebra is one of the most ignored sections of the CAT and which carries a lot of weightage. Let us first see what is the weightage in CAT. So although the exam does not give a fixed pattern, you can expect 8 to 12 questions from this section depending on previous year's papers. Also, the questions are moderate to difficult. At least 2 to 3 are easy, 2 to 3 are direct formula based, right? And the syllabus is limited in comparison to a geometry or a permutation and combination or a probability where the syllabus is very vast. So here the syllabus and the concepts which you have to learn are very limited, except some of the subparts such as functions and graphs. So if you cover this syllabus, which takes only a limited period of time, you can be assured that out of 8 to 12 questions, at least 6 or 7 of them you will be answering correctly, right? So let's begin. So again, these are the subparts. The various subparts within the algebra are linear and quadratic equations, the inequalities, algebraic equations, polynomials and graphs, logarithms, and there are various miscellaneous small concepts such as modulus, maxima and minima, etc. So let us first look at what is a linear equation. A linear equation is an equation where the highest power of any term is 1. So it can be of one variable or it can be of multiple variables. So algebra is basically the part of mathematics where we deal with variables instead of numbers. So in number systems, mostly we will play with numbers, its various parts, the multiplication, the factorization, etc., etc. But in algebra, we will deal with the variables, and here in the linear equation, the highest power of any term is 1, but there can be any number of variables. Say it can be an x plus 4 or x plus 4y or a plus b plus 4c plus 8d equal to 10. All these are different linear equations. So linear equations can be of with one variable, two variables, or more than two variables. So the number of variables is equal to the number of axes on which we can represent this equation. Okay, so definitely, as far as what we know, only three axes is what we can draw as of now, x, y, and z, and hence we can represent only linear equations of three variables on graph. So if it is a linear equation with one variable, the graph would be a straight line. If it is of two variables, it would be an xy two axis graph. If it is a linear equation of three variables, it will be an xy and z graph. Let us now come to the quadratic equations. A quadratic equation is an equation where the highest power of any term is 2. Everything else is similar to linear equation. So now the highest power is 2. It allows you to combine two variables together. So it may so happen, if you see in the third example, a plus ab plus cb plus ad. So the highest power of the term is 2. However, you can combine two of the variables in a particular term. So again, it can be of one variable, two variable, or more than two variables, and you can represent it in the number of axes equal to the number of variables graphically. So now let us look at the graphical representation of linear equations of two variables. As we have seen before, to represent linear equation of two variables, we need two axes. So we'll take an xy axis. We'll take a linear equation which is y equal to mx plus c. This is the common linear equation. Here y and x are the variables. M and c can be any numbers. Say y is equal to 4x plus 3, y is equal to 5x minus 2, right? It can be anything. So also y-axis equation is x is equal to 0 because all over the y-axis x is 0. Similarly, the equation of x-axis is y is equal to 0 because the height is equal to 0 so far as x-axis is concerned. Once you know this, you can also know the points where this line is touching that particular axis. So this line touches y-axis at a point where x is equal to 0. By substituting x is equal to 0 in this equation, we get y is equal to c. So 0 comma c is the point where it touches y-axis. Similarly, by substituting y equal to 0, the point where this line touches x-axis is minus c by m comma 0. So now this c is called the y-intercept. This minus c by m is called the x-intercept and m is called the slope. So far as algebra is concerned, as of now, this basics will be enough and we'll cover more details on the line in the geometry section. Also, to draw this line, you can take any 2 points in general and only 2 points are enough to draw a line. But the easiest method is always to take one x is equal to 0 and find the point on the y-axis and one y is equal to 0 and find the point on the x-axis, because you'll directly be eliminating one term. It is 0, right? So now let us look at the different types of lines which we can draw. This y is equal to x can be drawn in a limited number of ways. It can be drawn only in 4 different possibilities, right? So this case, first case which we see is the case where c is positive. If c is positive, the line intersects the y-axis at a positive point, at a point above 0, 0, right? So these are the 2 possibilities. Similarly, y equal to mx plus c, where c is less than 0, always the line intersects the y-axis where it is negative, the c is negative. So there are 2 possibilities. The line can be either on the right side or on the left side of this. So now let us look at the case where c is greater than 0 and m is less than 0. So now if m is less than 0, minus c by m will become positive, right? So the line will be something like this. If m is greater than 0 and c is also greater than 0, c by m is positive and minus c by m will be negative. So this line touches the x-axis on the left side. So it will be something like this. Now let us look at this case where c is less than 0. In this case, c is less than 0. If c is less than 0 and m is also less than 0, c by m will be positive and minus c by m will be negative. So again the line touches the x-axis on the left side. Similarly, if m is greater than 0 and c is less than 0, minus c by m will be positive. So it touches the x-axis on the right side. So these are the different lines. So your always a fallback method is take 2 points and draw a line, but you can just keep this in mind so that you can quickly understand, looking at the equation of the form y equal to mx plus c, how the line comes, right? Now let us look at the theory of quadratic equations. Now that we have completed some basics of the graphical representations of linear equations. See, we will now look at the quadratic equation of one variable first. So it will be of the form ax square plus bx plus c, where x is the variable, a, b and c can be any numbers, different numbers, right? So the values of x for which this equation holds good, like for this quadratic expression. So x square plus bx plus c is the quadratic expression. When you put an equal to 0 and equal to something, it becomes a quadratic equation. So if you write a quadratic equation of some form where the RHS is 0 and the values of x which you put into that quadratic equation, thereby resulting it being LHS is equal to RHS, that particular value or values of x are called the zeros of the quadratic equation, of the quadratic expression, or they are also known as the roots of the quadratic equation. So the maximum number of roots any quadratic equation can have is 2, and unless a equal to b equal to c equal to 0. In that case, it can have any number of roots. It is called an identity. Now the only important formula you have to remember in the quadratic equations is this. If alpha and beta are the roots of quadratic equations, then alpha plus beta is equal to minus b by a and alpha beta equal to c by a, where the quadratic equation is of the form ax square plus bx plus c. There will be a lot of other equations, but every other thing can be derived by using this single equation. So for starters, ensure that you know this equation very properly, and whenever an quadratic equation is given, bring it to the form of ax square plus bx plus c, and then you can know the sum of the roots is minus b by a and product of the roots is c by a, right? Next, so this is the most important thing, as I said. So graphically, any quadratic equation represents a parabola, right? So now let us take this sum of the roots and product of the roots formula, and we will derive all other properties which are important in this theory of quadratic equation. So this is the only formula which you should remember, just this formula. Even if you forget all other things, you can derive it in maybe a 20-second or 30-second time in the examination. So now we know that alpha plus beta equal to minus b by a and alpha beta equal to c by a, where alpha and beta are the roots. How can you find these roots? You can find the roots if you can find what is alpha minus beta. In that case, I have the equation for alpha plus beta. You'll have an equation for alpha minus beta. And then if you add both, you get 2 alpha. If you subtract both, you get 2 beta. And then you can find alpha and beta. So now let me try to find alpha minus beta. So what is the relation between alpha minus beta and alpha plus beta? Alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta, right? So now once this is clear, alpha minus beta whole square is equal to alpha plus beta is minus b by a. So minus b by a whole square, that equals b square by a square, and minus 4 alpha beta means minus 4 c by a. So this gives you b square minus 4ac divided by a square. This is alpha minus beta whole square. So what is alpha beta? Square root of this. Root over b square minus 4ac by a. Now you have alpha plus beta and alpha minus beta. So what will be your roots? What will be your alpha and beta? Alpha will be minus b plus root over b square minus 4ac by 2a. Beta will be minus b minus root over b square minus 4ac by 2a. So even if you forget this particular equation, that alpha equal to so and so, beta equal to so and so, you can just derive it on spot. It is very simple. Alpha minus beta whole square you will find, and then you will add to get alpha and you will subtract to get beta. So now once this comes, we will move to one most important thing. This expression b square minus 4ac, which is inside the square root, is called the discriminant. Now looking at the properties of the discriminant, we can understand a lot of properties about the roots of the equation. Let us see how. So now there are various properties of discriminants. I'm not asking you to remember any of these properties. You can always derive it on spot if you keep it in mind what is alpha plus beta and what is alpha beta. So once you know that, you will get two roots as minus b plus minus root over b square minus 4ac by 2a. Now let us look at this expression and we'll derive all the properties so that you need not mug them up. You will intuitively remember how this came, right? If d is equal to 0, so if this b square minus 4ac is equal to 0, the expression which is under the square root is 0. In that case, what is happening? Both of your roots are minus b by 2a, right? So the roots are real and equal, and they are equal to minus b by 2a. Now let us take a case where d is greater than 0. If d is greater than 0, root over b square minus 4ac is some real number, right? Because d is positive. In that case, minus b plus root over minus b square minus 4ac by 2a and minus b minus root over b square minus 4ac by 2a will be two different numbers, but they are again real numbers, right? So if d is greater than 0, the roots are real and distinct. If d is less than 0, what happens? If d is less than 0, square root of a negative number is imaginary, right? And if minus b, if b is any number other than 0, the roots will become complex roots because you have a real part and you have an imaginary part. If b is equal to 0, the roots are purely imaginary, right? Next, if d is a perfect square, what happens? You will get the square root of this perfect square as a proper number, right? A proper rational number. So the roots are rational numbers, right? But if d is not a perfect square, the roots will be irrational. See, here we derived all of this. Now, if j plus root k is one root, then j minus root k must be another root, because this is very clear. One root is minus b plus root over b square minus 4ac by 2a. The other root is minus b minus root over b square minus 4ac by 2a. If j plus root k is a root, then j minus root k must be a root. If j plus I is a root, then j minus I must also be a root. J plus ik is a root, then j minus ik must also be a root. Again, I is an imaginary number here. So when will that happen? It will happen when the d is less than 0. So if j plus ik is a root, then j minus ik will also be a root. So in this way, we have looked at the basic concepts of the linear equations and the quadratic equations, and we have looked at the graphical representations of the linear equations. In upcoming video, we will look at the graphical representation of the quadratic equations. Post that, once the concepts of the algebra, so far as these parts are done, we'll start solving the CAT previous paper exams related to this particular concept. Thank you.